In this video, we're going to have a look at how we can determine the equation of a linear line when we are given two arbitrary points and told that the line passes through them. In this case, we've got points A, which is at -2, 1, and B, which is at 2 and 3. Now, to do this, we're going to follow the same or similar method to what we did in examples 1A and 1B, in that we're firstly going to plot the 2 points and then graph the line itself. And then after that, we're going to calculate the gradient like we did above with a slightly different twist. And then we have to calculate the value of C because we're not given it in this example. So jumping straight into it, I'm going to plot points A and point B on the Cartesian plane. So point A is at -2, 1. So somewhere here, then up 1. Then B, we go across 2, up 3. Next step is I have to draw a line that passes through both of these points. Remember, the line doesn't stop the point, it goes through both of the points. Done. Okay, now that we've got that graphed, what we're going to do is we want to try and get it in the form of y equals mx plus c, where m represents our gradient and c represents our y-intercept. Now, firstly, to calculate the gradient, we have to use the gradient formula of m equals rise over run, or more easily put y2 minus y1 over x2 minus x1. Now, I'm often asked which one should be x2 and which one should be x1. The answer is it really doesn't matter so long as we're consistent. So if we say that this one is x1, then therefore this one must be y1, and similarly this would be x2, this one would have to be y2. Now, grabbing these values that we've defined up here, x2 is, I will start with y2 actually, it will be 3 take 1 all over 2 take -2, and therefore in this case m is going to equal that will be 2 over +4, and therefore m is equal to 1/2, like so. So therefore our equation y equals mx plus c is going to be rewritten as y equals 1/2. Now, next step is we need to deduce the value of c. Now, normally we could simply just put across there, look at it on the Cartesian plane, and by inspection we know it's going to come out as 0, 2. But imagine that the line itself didn't cut the y-axis in a very nice position. Imagine it cut like that, or it cut something like that, in which case we'd get a non-rational number there, and therefore it wouldn't be a very accurate depiction, or the line itself, the formula we come up with, wouldn't accurately depict the line exactly. So what we're going to do is we're going to use an algebraic method to determine the rest of the equation. So the way in which we do this is we pick either point A or B, doesn't matter. In this case I'm going to pick B, and we say let x, y equal to 3. And what this is going to do is, whenever we see the value of y, we're going to replace it with the number 3. So in this case, it will be 3 like that. And whenever we see the value x, we're going to replace it with the number 2, because that's what we've said we want to replace x and y with. So we're left with 3 equals 1/2 times 2 plus c. Now, simply by rearranging the equation, we're going to get 3 times 1/2 times 2 is 1 plus c. Rearranging all of this and taking 1 from both sides, what we end up with is, that came out strange, I have to make do. What we come out with is 2 equals c, and then flipping everything about, c is equal to 2. So therefore we find that the equation of this line is equal to 1/2 x plus 2. Therefore determining the equation of this particular line here. So looking back, to do this, first we graph the 2 points. Then we calculate our gradient from the values that we deduce, or the values of these 2 points, and then we write out the equation as is with plus c, sub in either a or b, so x and y, and then deduce the value of c, thus giving us the equation of the line. Let's have another go down here. In example 2b, so we've got points a and b, -3 and -2, and 4 and -1. Plotting these, we're going to get -3 is back here, then down to, so that's a, -3, -2, then b is 4, 1, 1, 2, 3, 4, and then down 1. Alright, cool. Now, we're going to follow the same process as we did before. So we've got a and b. A is -3, -2. B is 4, -1. And we're trying to get it in the form of y equals mx plus c. We need to find the value of m, and we know m is equal to the rise over the run, or y2 take y1, all over x2 take x1. And let's just say that we'll give this a value of x2, and therefore this is y2, and then this is x1, this is y1. Subbing in those values, y2 is now -2, take -1, and then we're going to get the x values, -3, take 4. It's going to come out a bit different. M is going to equal -2 take -1, well, that becomes -2 plus 1, which then becomes -1 all over -3 minus 4, and then it's -7. So therefore our value of M is going to be positive a seventh, which is a little bit messy because that's not a rational number. So what we end up with is y equals 1/7 x plus c. Let me write that a bit. It looks a little bit ambiguous there. There we go. 1/7 of x plus c. Now we have to pick either a or b. In example 1, we picked b. In this one, let's go for a, just to change it up a bit. So we'll go let x, y equal to -3, -2, and therefore 1/7 times -3 plus c, and then on the left hand side it's -2 because that's our value of y there. Solving this, we get -3/7 minus 2 plus c. And we don't really like working with fractions. So how about we get rid of the fraction by multiplying everything by 7. So this will be, let's get rid of that. We'll go times 7 times 7. So that will become -14 minus 3 plus 7c. And then adding plus 3 to both sides, what we wind up is, that will be -11 is equal to 7c. And then rearranging, we get 7c equals -11, and therefore c is equal to -11/7, because we divide both sides by 7. So therefore our equation of this line is going to come out as y equals 1/7 x take 11/7. So remember how I was talking about in example 1, we can't really determine the value of c by looking at the graph, because look at over here, that's we can't get an exact value out of that. But if we use the algebraic method as we've seen over here, then we can actually get that algebraic, or we can get that exact value. So putting that in, we find that it cuts at 11/7 there. So In summary, this has been a video where we have learned how to deduce the equation of a line when we are given two arbitrary points which said line cuts through.